This is FE Peer Review. The date is February the 5th, 2022. Kyle Adams claims the sun's rays reaching Earth are not parallel, but can he tell us how out of parallel they are? A couple of days back, we had the pleasure of listening to Mr. Sensible have a conversation with Kyle Adams. Among the issues that came up was the Umbra-Penumbra effect and its relationship with the angular size of the sun. I think there were some possible misconceptions in the minds of some people, Kyle Adams included, but not only Kyle Adams. I think some among the people in the side chat might have also I think we're confusing the issue of the sun's parallel rays and the Umbra-Penumbra effect, and they're really kind of two different things. They're related, but they're not closely related as some people might expect. So I've put together a little set of diagrams here that I think will walk us through this. What we have here in the first diagram is just a quick recap of the Umbra-Penumbra effect and what causes it. So we can imagine that there's a ground plane and there's some kind of a stick or a lamppost or some kind of tall object like that. And then up in the sky there's our sun, which has some particular angular size. It's approximately half a degree. We'll call it half a degree. Keep things simple. And that sun is casting light onto that stick, and the result is a shadow, but the shadow is not a crisp, sharp line because the sun is not a point source. If the sun were an infinitesimal point source of light, there would be no penumbra. There would be just a shadow with a strict edge, sharp edge. But because some of the light from this side of the sun is casting down this direction, some of the light from this side of the sun is casting over that and obscuring or illuminating some of the shadow of the first ray of light, we get this Umbra-Penumbra effect. Along the center line here, we'll have the full shadow. But to each side, the shadow gets diluted by sun rays coming from other parts of the sun. So now let's go to our next slide, and let's say we have two of these, some distance apart, doesn't really matter how much, 10 miles, 100 miles, 1,000 miles. The exact same thing is happening to the lamppost 100 miles away. And this red line here and this red line on the left, they are effectively parallel. They are not a half degree off. This has nothing to do with the angular size of the sun. They are very, very slightly out of parallel, but the reason for that is something much different. And it's so small compared to the angular size of the sun that it has no real impact on anything we can see or measure when it comes to the Umbra-Penumbra. So we've got the sun 93 million miles away, 149 million kilometers away, casting light on these two sticks, and that central line, that red line on each of them, is parallel. Almost parallel. Okay, now we're going to get into the almost. So here's our next diagram. On the right we have a distant sun, and on the left an Earth, and we've got an observer at 45 degrees north latitude on Earth. That observer is looking very far away to the sun on the right, and we see again that there are sun rays coming from the top surface of the sun, we'll call that the top, coming down and reaching the observer, and there's rays at the bottom coming up and reaching the observer, and we know from measuring that this angular size is roughly half a degree. 33 minutes, something like that. Arc minutes. But if you basically add all those rays up, you have, they sum to a line that passes from the center of the sun to the observer. It's basically a symmetrical arrangement with them all coming to the observer. Now we're going to add a second observer at 45 degrees south latitude. So that observer is seeing the red lines here. They're getting lines from the same top and bottom surfaces, and they are also getting a line, a sun ray coming from the center of the sun to their location. So this is where we get into the rays of the sun not being parallel. Again, this has nothing to do with the angular size of the sun being a half a degree. What we're interested in is really the angular size of the Earth from the perspective of the sun. That's the key here. It's not the angular size of the sun as viewed from the Earth that matters. It's the angular size of the Earth as viewed from the sun. So yeah, this green line and this red line, that one there, those two lines are not parallel. The center lines of the sun reaching each point on Earth are not parallel. And it's that angle between them that concerns us. It's not this angle or this angle. It's this one. To reinforce that point, I'm going to point something out here. The angular size of the sun as seen from the Earth depends on the size of the sun, and it gives us that angle there or that angle there. But this angle, the angular size of the Earth as seen from the sun, the diameter of the sun's irrelevant. This angle is dependent on the diameter of the sun. This angle is dependent on the diameter of the sun. This angle is dependent on the diameter of the Earth. So let's suppose that the sun were in the same position but much smaller. So I've drawn in a smaller sun here. And yeah, absolutely, if the sun were smaller, the Umbra Penumbra effect on Earth would be affected. Instead of having this half a degree angular size sun, we'd have something much smaller, so the penumbra would be smaller. But the out of parallelness of the light rays reaching our two observers has not changed at all. Zero, no change. It's still the same as it was with the larger sun. So this is why we can't, this is why it's a mistake to think that this angular size of a half a degree of the sun has something to do with the rays being out of parallel when they reach the Earth. They're really two geometrically different problems. So what it comes down to is we want to know what this angle is, the angle between these two lines. And that is simply an isosceles triangle. These are the two equal legs, and the base of our isosceles triangle is the chord length, the straight line distance between our two observers, not the distance along the surface of the sphere, but rather just the straight line across. So that's the isosceles triangle we want to solve for this angle here. And down in this bottom here, I'm not going to go through every step of it. I've done the math. You can always pause it and read through. I'll just quickly go through it. The chord length I've divided in half and called half of it b, little b. And I've gotten the half chord length. And then I've used that and a right triangle, so I'm looking at half the isosceles triangle. I'm using our half chord length, our distance to the sun, to get half the angle big B that we're interested in. Multiply that by 2, and we get our out of parallelness of the sun's rays for an observer at 45 north and an observer at 45 south as 12.6 arc seconds. So we're looking at 12.6 arc seconds out of parallel. That's something like 140th of the angular size of the sun. So it's several orders of magnitude smaller. This is why I think people were making a mistake when they're thinking about the sun's rays not being parallel when they reach the Earth. This is how close to parallel they are. So if your name is Kyle Adams and you want to go on to a debate or discussion program and insist about the sun's rays not being parallel, you now know how much not parallel they are. Like tiny, tiny, tiny amount. So small that you, Kyle, will never be able to observe or measure the effect. It has no effect on what you see. Now, if you want to try to cast doubt in people's minds about the sun rays being parallel for some reason, well, they aren't parallel. That's how small they are. Now, refraction, atmospheric refraction, is orders of magnitude more significant than this business. So sure, we can talk about refraction and how that influences observations if you want to do that. But this business about the sun rays not really being parallel is a lot of hooey. It's just a lot of wordplay. So if that's how you want to find common ground with people, by messing around with all this kind of wordplay, that's your choice. But if you're going to do that, you probably want to be able to back up your wordplay with numbers, and I've given you the numbers here. So now you don't have to do it yourself. You just have to understand this. However, I think next time I may call you out and not give you the numbers. Just point out how to get the numbers and wait and see if you ever even bother to try. All right, enough of that. It was a good discussion between Mr. Sensible and Kyle Adams. I think that this whole business about sun rays not being parallel is a bunch of nonsense, totally unproductive, and really just an attempt on Adams' part to confuse the issue. Anyway, that's my opinion. If you're enjoying this video, hit that like button, subscribe, leave a comment. Have a good day. Have a great weekend. Bye-bye.